Hello everybody and welcome to this wonderful course about OWASP. Now in the OWASP top 10 we've had some changes in 2021. First of all, XXE and XSS are no longer with us, and so is insecurity serialization. They have gone from the top 10, but that doesn't mean they have disappeared, of course, so be mindful of that. Following are new insecure design, software and data integrity fails. And then we have SSRF on the top 10 as well, taking spot number 10. First of all, let's start with A05, broken access control. It moved all the way from number 5 to number 1 in 2021. That's a great thing, of course, because I love broken access control. I love testing for it. Then we also have sensitive data exposure, which moved from spot number 3 to spot number 2 into cryptographic failures. Security misconfigurations on spot number 6 moved to spot number 5. The number 9 spot, known vulnerabilities, went to spot number 6, vulnerable and outdated components. Spot number 10, insufficient logging and monitoring, went all the way up to 9, one big jump. And then we have A01, of course, injection, moving down to number 3, being knocked off its throne by broken access control. And we have broken authentication, which moved from spot number 2 onto spot number 7 as identification and authentication failures. Of course, we will be going into each of these topics individually in this course, so make sure you stay tuned, my friends. Alright, so let's move into broken access control to start with. As for the 2021 updates, of course, this vulnerability is now in first place, and I really recommend you to look into this vulnerability type, especially as bug bounty hunters, because as you guys might guess, second order IDORs are broken access controls as well, and they are often overlooked second order broken access control issues in general. So what do we mean by that? We'll go into that later. First of all, a small introduction. What is broken access control? Of course, you can have, for example, different levels of access, like you have an administrator who can do everything, edit settings, edit invoices and view invoices. A salesperson can edit and view invoices but not edit settings, whereas your reporter can only view invoices. The admin can edit settings, but if the reporter can edit these settings as well, even though he is not supposed to, that is broken access control. It can manifest in various forms. It can manifest in vertical or horizontal broken access control. Now, what does that mean? It means that I can either see invoices of other users, for example, where I am allowed to use the functionality but only see my own data. And that's what we usually call IDOR, because there's usually an identifier involved, insecure direct object reference. That object reference is an identifier. Or we can have your vertical broken access control, which is where you can execute functionality which you're not supposed to be able to execute. And of course, these arrows are in the wrong direction for that. If a user is able to execute admin functionality, then we have our vertical broken access control. So let's talk about first and second order IDORs as well. I think it is very important because I think it's often overlooked. Now, what's a second order IDOR? My user itself might not directly be able to go into the invoices, but he might be able to print documents, and he can give that document an identifier which belongs to an invoice. So he might be able to see invoices. That way you have to think outside of the box a little bit. And you also have to know that if there's 10 different privilege levels, then you want to test with those 10 different privilege levels and all of the functionality that they're not supposed to be able to execute, both horizontally and vertically. And that might be a while. It might take you a little bit longer, but it will allow you to find bugs which other people might miss. I think it's very important to test like this. Now, how to test specifically for broken access control, I'll put some more practical videos in as well. But I think that's also important to realize that most of these broken access control issues happen because of either scope creep, which is where much more scope is added to the project later on than first was initially discussed, or it can happen because you're building an application now and making changes a year into the future but don't really remember what it was like, or you're integrating with an external party and you might have a misconfiguration there allowing for the IDORs. For example, an import module that you're not fully controlling, and it might overwrite items that are not yours, even though you're not supposed to. That might be your IDORs. All of these different things, it's important to take them into account. And you have to make, in my opinion, when it comes to methodology, you have to make yourself a handy overview like I have right here, where you have the different user privilege levels. And let me zoom into that a little bit. So let's say HR person, a salesperson, an administrator, and a customer success manager. The customer success manager is only able to create and read invoices and quotes. He cannot update or delete them. He cannot edit the settings or anything from the users either, whereas the admin can do anything. As you can see, CRUD, create, read, update, and delete. That's what that stands for, in case you didn't know. Everything that is green, so if it's green, create, he can do that. If it's not, he cannot do that functionally. I still have to test if it's really true, and that's gonna be my broken access control testing. Now, why does this happen, these 403s? Well, basically, you really have to remember that sometimes flow matters as well. Sometimes you have a flow that you have to take into account, and you might not be able to skip the last step, but you might be able to find a broken access control or an IDOR on one part of that fully functional flow from A to Z, where it has a few steps in it, a few calls. It might not be obvious immediately because you might only be looking at the last request, but there might be some calls in between that you have to check as well. To make sure that you have everything checked off, use an extension for Burp Suite like authorize. It's very important because it will speed up your testing a lot, and it will make sure that you don't forget anything. Now, to summarize, broken access control is if we are logged in at all. That is also something that we have to take into account, authenticated versus unauthenticated users. Sometimes you might find that you might not have a broken access control while you're logged in, but suddenly if you're logged out, you might be able to execute functionality that you're not supposed to be able to execute. That's why Authorize is so great, it tests it for you. Broken access control, so you have to, all of this is basically a checklist that you can go through. All of these things are things that you have to check, and you have to check it very diligently with every single user. I'm sorry that I keep repeating that, but it's super important that every single user type is tested. Sometimes, or even often, it will also be a combination of different user rights. And when I can granularly edit a user's rights, what he can and cannot do, that is perfect for me. If I can add them to a certain group and that group has a specific set of rights, I can play around with that. But if I can add combinations of user rights and not have to indicate a group, that is excellent for me. So you really have to make sure, of course, that in this case, you want to deny access to any resource by default and only allow access where it should be accessible. That is the whitelisting principle. Of course, you have to do it based on a regular expression or something like that. And I know that it is very tedious to set up correctly to make sure that everything stays working the way it's intended to work. But it is the most secure way to work. You also want to create a reusable method for authorization and implement it throughout the application, not just implement the authorization every single time, because then you might risk duplication of code, maintenance issues, but most of all, you might risk introducing vulnerabilities in a part of the website without realizing it. It's called the security factory. Now, there should also be a matrix displaying which users are able to access what functionality. I think it's very important, it's that Excel thing that I showed you, that it exists for your application, because then your QA and your testers can see if it actually works the way it's intended to, or you can even write unit tests based on that. Make sure that you also disable directory listings on your web server and that no metadata information like Git files are visible. Any logged in that is failing, or if they don't, like if they try to access functionality that they should not be accessing, for example, an invoice that is not mine, or executing user settings changes where I should not be able to, well, those attempts should be logged as well, and there should be an appropriate alert sent out to either a tech lead or a manager as well. You want to rate limit all of your APIs so that tools are not going to interfere with your normal operations. And you want to make sure that authorization headers should have a limited validity and they should be disabled upon logging out of a user. This is so that if a user gets hacked, okay, they're hacked, but it's only valid until they log it out. If we follow all of those tips, you negate a lot of the attempts of abusing broken access control, plus you log it and you have an alert on it. So you're well on your way to prevent it, I'd say. Of course, 100% security is never possible, but it's already a big step. So how can we test for all of this? We have either a copy or paste method, in which case we're going to log in as an admin, open the functionality only an admin can see, copy that URL, log into an incognito window as a low privileged user, and paste that URL in the incognito window. So we have an admin, we're logged in as an admin, copy that URL and paste it in the bar of our low privilege user. If that functionality loads where it should not, then of course we have a broken access control. But of course you can imagine if you have a lot of different users, then it gets messy real quick because you can't keep opening different browsers and incognito windows. So to help, you can of course use plugins as well, such as PwnFox, to containerize your tabs. If you do that, you can simply open a new tab and log in as a specific user in that tab, having a separate session. Now you can also copy and paste JavaScript methods. What do I mean by that? You can literally inspect any part of a web page, and I'm trying to right now, but Notion is not letting me. So you can inspect any part of a web page, go to the console, and if you know JavaScript methods, like if, for example, you find a button and it says delete user, you can log in as a low privilege user in your window here. Then you can try that delete user functionality, and maybe it takes a user identifier, or you don't even need that, like that, for example. That is something that you can try to execute JavaScript functions as well. If you paste those in your developer console of low privilege user and you get your results where you shouldn't, of course you have another broken access control issue. As you can imagine, that also can get messy, but you have to make sure that you, in this case, again, you're logged in as a different user in every single window. So make sure that you either have PwnFox installed or that you have another extension installed that makes separation of user sessions possible per tab. or that you log in with enough browsers. If you have 10 different user levels, that'll be difficult though. Now you can also change the authorization headers in repeater. So in this case, the procedure is you're gonna open your man-in-the-middle proxy, such as Burp Suite. You're gonna log in as a low privileged user, and then you're gonna copy their authorization headers. Then you're gonna execute admin functionality, and you're gonna keep pasting over those headers. Now, why does this matter? Because if I can then execute my functionality and get a response like 200 OK with a body where I shouldn't, of course I have another broken access control because I'm logged in as the low privileged user. I'm using their authorization header. I hope that makes sense. Then of course we can use match and replace as well. We can use authorize, we can use auto repeater. There are many plugins available for testing, and of course in OWASP Zap we have the access control plugin as well, which can test for access control automatically, which is really good as well, because then if you have another level of access control, you can literally just add it. The thing is I love Zap's solution because you can test with like 20 different access levels at the same time, whereas with Burp Suite you're gonna have to do it one at a time. Now make sure that you also test by changing the request method. You can do this in Burp Suite by clicking changing request method, and of course there are quite a few CWEs mapped to this. But that's broken access control in a nutshell. Again, I'll add some more practical videos after this one, but we'll move on to the second chapter for now as well, for the recordings at least, because the other ones have been recorded already. See you soon, my friends. Okay, my friends, we'll move on to cryptographic failures. Now, what you need to know is that this wasn't known as cryptographic failures previously. This was known as sensitive data exposure. And a lot of mystery surrounds this topic, of course, because what is sensitive data? Are we talking about API keys? Are we talking about passwords? Well, it's strange because, of course, some API keys and passwords are meant to be public. For example, well, of course, not passwords, API keys, I mean, of course. If I have a public API, I might need an API key per user, per session, or whatever. Well, then, of course, that API key is supposed to be public. Or, for example, if I built an application and it uses Google Maps, I need an API key to use that Google Maps thing. Well, of course, that API key is supposed to be public. Now, you can look at those. You can think, okay, is this supposed to be public or not? But it's always going to be judged per client, per victim that you're attacking. Now, of course, this can be as simple as just pasting a post-it on your monitor with a password on it. That is a very, very obvious one. Debug information is often very useful as well. GitHub repositories that have passwords. Now look in the repository itself, but also look in the commit history if maybe somebody didn't erase a password. Look at somebody's Twitter profile. Some employee might accidentally tweet some sensitive information. For example, they might take a picture at the office of the entire team, and that picture might contain a post-it note, like we said before, on a monitor, and they might not even notice it, or it can even be like a poster behind the team, whereas they might not even notice it. It's just an innocent picture to that manager. Make sure that you watch that social media like Twitter, like LinkedIn. Also make sure that you notice that a web server might contain configuration files that are visible to us, so we can visit those configuration files sometimes. That's also sensitive data exposure. And look at the source code. I cannot tell you guys this enough. Source code for comments, source code for JavaScript files. And then of course directory listings are also not supposed to be public. There are physical threats when it comes to this. There's debug information which might be available. For example, if the debug information says wrong email or password entered, that is not very useful. That is pretty useless information. But you might find some information like, oh, you typed in this value, but I only allow these values. If it tells you what values it allows, of course, not a good thing. That is something that should be watched out for. You should always look in Git as well. And then, of course, you need Twitter, you need LinkedIn, you need to check Facebook, you need to check people who work there, and maybe even check company pictures. All of this might be useful information. When it comes to configuration files, make sure that you are not exposing them, and of course, make sure that you configure your server correctly, because if you don't, you might still be exposing sensitive information. For example, an incorrectly configured S3 bucket. That's something that you should always watch out for. Then JavaScript, you might have JavaScript things in there like passwords, like paths, like API keys. All of these things might be in your JavaScript file, and I have an excellent article and video about how to analyze JavaScript as well. So we'll add that to this chapter just so you guys are a little bit aware of that. You can use several methods for that. And then, of course, we have directory listings. Make sure that you don't expose those, and make sure that you don't expose backup files. Now, if you want to test for information disclosure, don't focus too much on testing for information disclosure. Do it as you're testing and try to notice these things. Make sure that you look everywhere and don't just, like, I've covered a few things in here, but make sure that you cover everything, because of course sensitive data can be exposed anywhere. Usually you will not find that information when you're looking for it specifically. So again, try to do it differently and try to look for that while you're testing. I have a little bit of a checklist in here as well. Like the physical threads, the debug information, the Git, the social media, comments of HTML and JavaScript file, directory listings enabled, and backup files enabled. Now, how vulnerable that information is, that sensitive information, that really depends on what you are as a core business, of course, or what you are attacking as a core business. Is this something that affects their core business of the client? Then, of course, this is a pretty eventful thing. You have to note it as a high or critical vulnerability then as well. When it comes to conclusions for this, make sure that you don't leak any sensitive information. Of course, that's easier said than done. There are some CWEs listed here as well, quite a lot of them, to be honest. So, if you want, I would definitely recommend looking more into these to get a better idea of what is considered sensitive information and what is not. I'll see you in the next one. So when it comes to number 3, injections, there's many different types of injections, like SQL injection, NoSQL injection, LDAP injection, HTML injection. There's a lot of types of injections possible, and I want you to know that, of course, we can't cover every single topic into extreme detail, so it's important that you look into some of these yourself as well. SQL injection is the most basic one, where you enter a single quote and a double quote and you try to lure out any SQL errors, and then if you find any, you go on with SQL map to test for those SQL injections. But there's also NoSQL injections, and there's also OS command injections. And we have another broad category of injection types in here. Now, this one it's not that easy. And of course, I have some labs for this as well. Make sure that you understand that many different types of injection are possible. So the ones that I know of are XPath injection, LDAP injection, HTML injection, SQL injection, NoSQL injection. There's more, I'm sure of it, but I can't immediately come up with them. But as you can see, there's quite a lot of CWEs appointed to the injection category as well. When it comes to testing for injections, of course, then you have to go and look at every single issue type in and of itself, and you have to see how to test for it. Now, I have some labs on XPath injection. I couldn't make some on SQL injection in time for this course, but if there are any, I will definitely add them, of course. And there are some HTML injections possible on the cross-site scripting labs and pretty much most of my labs as well. So those are some interesting things that you can try, of course. I will put the labs in a separate file. Now, insecure design, if the previous topic didn't have a lot of mystery surrounding it, this one definitely does, because there's so much that can be counted as insecure design. Now, of course, there are security design patterns as well. These can be either on the architectural level, like the distrustful composition. These can be design level patterns like secure factory, secure builder factory, and secure chain of responsibilities. We can also have implementation level patterns like secure loggers, for example. And this is something that has to be monitored very closely. As you can see, this list of CVEs almost seems endless, but it even includes things like business logic flaws, reliance on security through obscurity, external control of critical state data, and trust boundary validation. And that's just a few of the ones that are listed under this topic. So dive into these. This will give you an idea of what is considered insecure design and what is not. And of course, if you're a pen tester, you should not report insufficient, if you're a bug bounty hunter, that is, of course, you really shouldn't report some of these. Of course, you should report your business logic flaws. But violation of secure design principles, that is a tough one to sell on a bug bounty program. Let me just put it that way. So as for security misconfigurations, that can happen a lot, and especially when thinking about cloud, hybrid, on-site environments. Because then there's a lot of configuration that goes into this, and when it comes to COVID, we've all seen that work from home is possible, more configuration. Of course, it's easy to have a security misconfiguration in here. Now, not having sufficient security hardening across any part of the application stack, including the API security, is part of this. Of course, most applications these days, they should consist, and especially if they're big enough, of complete technical solutions, and the issues might arise in one of these components. If they don't have it, then of course there's a problem. Now, when our target uses cloud services, as I said before, then you have to configure authentication and authorization properly, especially if it's being passed around between different services. And of course, if your features are enabled when they are not being used, that can lead to some dangerous things. So disable all endpoints that are not used in a production environment. Some administrators are lazy. They might leave passwords in super easy to guess or default states like test or admin or admin test. We've all tried it. Keep on trying that, definitely. Even if you haven't found anything yet, you might soon, who knows. Now, our target needs to keep its systems and dependencies up to date. Besides keeping them up to date, we need to make sure the components are enabled and configured properly. And if any of the settings surrounding security is set to an insecure value, that's also, of course, considered a security misconfiguration. When the server doesn't respond with security headers or directives, of course, when set, they should contain appropriate security values. Those are security headers, CSV, cores, etc. To prevent these kinds of vulnerabilities, we can implement some mitigations as well. And all of those best practices serve to cover a particular goal, but we also need to know what these goals are so we can test them with precision, like cloud storage misconfiguration, test network infrastructure configuration, application platform config, alternative HTTP methods. If an HTTP method is enabled while it should not be, that's also a misconfiguration. And your HTTP strict transport security that forces the website to use this HTTPS while the browser basically. Now, of course, we can test infrastructure configurations, cloud. We've been over this already a little bit. I talk a little bit more about it, but it's hard to describe all of this in detail in a short amount of time. We don't want to drag this on for hours either. We just want to give you guys a basic overview before you can dive into the CWEs. Now, there are some examples as well of a person hunting down an API key and grabbing $300 bounty. The report is in the article itself. And there's a lot of examples that you can look up and think of when it comes to security misconfigurations. Now, there's a lot of CWEs assigned to this, as I said before, not as much as insecure design, of course, but still you have to test for all of these CWEs, every single one of them, if you want to test properly for security misconfigurations as a pen tester.